Today we're here to talk to you about something that's super cool that helps millions of people breathe every day. That is going to be called zeolite, and that's what this is right here. And we're going to be going over what this does, what it's used for, and how it works inside these portable concentrators. It truly is the unsung hero inside any either stationary concentrator or portable concentrator. All right, so first things first, what is zeolite? Zeolite is a microporous, crystalline aluminosilicate mineral. And that sounds like a lot, but just think about it as like a microporous sponge that's able to soak up things. Zeolite is made primarily of silicon, aluminum, and oxygen. The way they're arranged, it's able to create very microporous sections, so it's able to capture molecules that are very, very small. Zeolite is formed either naturally, typically from volcanoes, or it can be synthesized in labs, which is what typically we're using in oxygen concentrators today. Zeolite is very helpful in many different areas, including water softening, dehydrating, agriculture, and most importantly, what we're talking about today is gas separation. So how does sieve actually work? So it's all about selective absorption, molecules that fit perfectly into pores and interact favorably with internal surfaces get trapped. Others that are too big, the wrong shape, or less attracted simply pass by. Zeolite can also change ions and release adsorbed stuff when conditions change, like pressure or temperature. This regenerability is key for repeated purpose. Now let's get into the really practical part, how it makes oxygen concentrators work. Oxygen concentrators are game changers for people with respiratory issues because they extract oxygen directly from room air instead of relying on heavy tanks. And zeolite molecular sieves are at the heart of the pressure swing adsorption process. Here's how it works step by step. First step is compression. Room air, about 21% oxygen, 78% nitrogen, plus traces of other gases, is drawn in and compressed. The second step is absorption phase. The compressed air is pushed into a column packed with zeolite pellets or beads. Nitrogen molecules are preferentially absorbed. They get trapped inside the zeolite pores because of their size, shape, and stronger interaction with the cations in the framework. Oxygen molecules pass through more easily and exit as an oxygen-rich stream, typically about 90 to 95% pure oxygen for medical use. And that brings us into the third step, which is product delivery. It delivers the medical grade oxygen to the end user. Along with bringing product to the end user, it does go in through a desorption or regenerative process. When the zeolite bed gets saturated with nitrogen, the pressure is lowered, the nitrogen is released and vented out. The zeolite is regenerated and ready for the next cycle. Most concentrators use two columns that alternate. One is absorbing while the other one is regenerating. This allows continuous oxygen production. This is why home oxygen concentrators are small, compact, and can run nearly 24/7 with electricity applied. Zeolite doesn't just separate gases, it does it without cryogenic cooling or complex chemistry. It is a perfect example of materials science solving real-life problems. All right, so there you have it. Zeolite is nature's way of taking normal room air and making it medical-grade oxygen. If you or someone you know uses an oxygen concentrator, now you know the magic that's happening inside.